Hi, this is John Waddick back again for another version of LabView for Chapter 2 in Engineering 161. We're going to look at some basic functions and get you going into some neat programming toward the end problems. But let's start out with our first tutorial, which is 2.1, which appears in your textbook on pages 28 to 36. You can follow along in the book if you like, or I will just step you through right here. Now, we've done this kind of thing in Chapter 1, but I'm just going to do a quick review. So you see the finished product. I have, remember, window, tile left, right. That brings me both the block diagram on the right and the front panel on the left. To get my name on here, I'm just going to do the same VI just below just to show you how I got all these things. Okay, so for my name, remember, you can just double click on the block and just type in your name and what problem it is. So I'd like to see your name on every one of these programs, or they're sometimes called VIs for virtual instruments. Okay, 2-1. All right, so you can just type that. Now, once you have it on the front panel, you can just hit Control on the keyboard. I'm hitting Control. I drag it over, and you can get the same thing on your block diagram. First step in creating any program is to right-click on the front panel, and let's get our controls. Okay, so we're going to bring in drag a control. Okay, now once you have one, I'm going to block that in. I'm going to hit Control again. That's going to create another control. Controls are things that allow me to put numbers in. Okay, on the right, so what I'm going to do is subtract two numbers, no earth-shaking thing here. Now on the right here, notice this is grade. This is an indicator. It's going to be the result of a calculation. So notice that that's grayed out. It doesn't have the white. It doesn't have the handles on the left like like the controls do. So I'm going to right-click numeric, and I'm going to put an indicator. So I drag that in. Okay. Now you want to have labels that are indicative of what is represented inside them. So this one is minuend. Now I can't use the same thing because I have it above, so I'm just going to make it minuend 1, and this one subtractand. Now you have to be a real math connoisseur to be up on these terms. And then out here, I'm just going to put difference. Okay. All right, so once you got those, remember, if you want to line them up better, I can box them all in. I can come up here and I can say vertical centers. I can vertical. There's also something here where I can make them equal distance apart. Now, how do I get the equal sign in here? Well, just double click and just type in equals. All right, if you want to change the size or bold or something, you just double click on the thing you typed, and up here in the text settings, you can change its size, style. So I'm going to make it bold. Wow, that didn't look very bold there. Style, size, style, bold. Okay. Color. I don't know. I'm going to mess with the color. Red. It made it red. Okay. Well, it's not a very good bold if you ask me. So style, bold, size. I don't know. Make it big. Okay. There we go. All right. So you can mess around. You can put an equal sign. You can put a minus sign here. Or if you want to make a line that's nice and thick, you can right click. There's these things called decorations. So I'm going to bring a thick line in. Okay, comes in at a slant. I just change its size a little bit, and come on, move down. There it goes. And I can move it down, and I use the arrow keys down, left, right. Okay, so there we go. On the block diagram over here, if you're going to take something and subtract, you're going to need a function. So I'm going to come over here on the block diagram. I right click. Numeric is where you're going to find a lot of the basic things. I drag in a minus. Notice when I hover over that, notice it has two dots on the left. Those are the input terminals. And on the right you have a dot, and that is the output terminal. Now, although minus, this is a pretty self-explanatory function, I want you always in the habit of putting labels onto your functions. Notice I have subtract here. So just get in the habit, right click, visible items, label. Okay, it'll give you the name so that if someone else is doing this and it's not an obvious one, they can see it. So please get in the habit of labeling your functions. And I'm probably going to have a question about that on your homework sheet. All right, so I just wire these in, and away we go. And then I'm done. Now, once I'm done, I can run this. Remember, we can run it in two ways. One shot, which means it runs it with what was in there before I hit run. Or it's probably going to be better for you on this to just run continuous. Okay, so you can put in different values, 10 and 2, and it keeps running live. Okay, I'm going to put a 7 and a 6 and a 5 in. Okay, looks like everything is working great on this one. So you learned about decorations and you learned about how to put in labels for your functions. Really important as we get into some more arcane, which means less easily recognized functions. All right, so that's tutorial 2.1. So I'm going to stop, or which it calls abort the execution here. And now I'm just going to close this. I'm not going to save any changes, but let's go and do tutorial 2.2. Okay, so here's 2.2. Now what I want you to do is make your front panel look like the figure 221. So that's on page 39 at the bottom. So figure 221. Now the one thing I have missing here is I don't have a box around. So let me show you how to do the box. So I'm going to right click, and there's decorations. Now I'd like to be able to use some of these boxes and maybe use different kinds of fills, but I have having trouble with those. So let's just use a flat frame. Okay, so I'll bring the flat frame in here and I'll go like that. So we can make a box around things by using decorations. Now the stop is behind the line here. Well, unlike other CAD softwares, it doesn't look like LabView it doesn't have a thing send to front, send to back where you can put different ordering. Maybe there is somewhere, but I can't find it. So what happens is whatever item you create last will be on top. So since that's the case and I don't want that right on there, I'm just going to move my box just to the right a little bit, and I'll have my stop. So this we want a box around here. So these are, once again, you have two numeric controls. You've got some text. You got a line there. This is a numeric indicator. Now what about this other stuff? All right, let's go to the block diagram. Now in this case I'm showing you full screen because I can't see everything when I have a tile left right very easily. So I'll go to tile left right, or I can just do show block diagram. So there's block diagram. I'm going to just hit maximize. So here's my block diagram. All right, so we have something new here. In fact, let's click on this. I don't know if I can show visible items. I can. I want to put a label on here. So I really should have a label on this. So it says while loop. Okay, I'm missing a label here. So I'm going to label that, multiply, and label there, add. Okay, sometimes when you print these out, it's really hard to see whether this is an add or divide. So once again, please right click, go to visible items, label. Okay. Now I've got a while loop. So where do you find a while loop, and what the heck does this thing do? Okay. So what you're going to do is first in creating this is you're going to create a while loop. So we're going to right click, and I'm going to go to structures, and the second one is a while loop. So I drag that in, I bring it in, and I box in an area and hit click. All right, it has something here. It's a little stop sign. It's the loop control. All right, there's a little iterator here. We're not going to use that here. Later on, we're going to review while loops again. But I'm going to right click on this visible items just to tell everybody, hey, this is a while loop. All right, so in this while loop, I want to put all these other items in. So I have already done that up here. Now, one of the things that you need to do is have some way to stop a while loop, because once you enter a while loop, this is going to continue as long as this stop doesn't make the loop end. Right now, there's nothing connected to this loop condition. Okay, so what I'm going to do is right click, let's see, and I'm going to create a constant. No, I'm not going to do that. Okay, so let's undo, edit, undo, edit, undo. Okay, let's create a control. Okay, so this is a stop button. Now, when I create that stop button, I'm just going to go and show you that it's also, because that's a control, tile left, right, it creates another stop button up here. All right, so you're going to get a stop button on the front panel. All right, so the stop button is something that's going to control when this loop stops. When this is true, in fact, let's look at this. The control for the loop says it's going to stop if true. So if I hit this button, it's going to be true, and then this thing is going to stop. All right, you're going to bring some things outside of the loop, like I have up here. Okay, we're going to put this is a Boolean indicator. All right, to get indicators, we need to be over here on this side. I'm sorry, and we're going to put a Boolean indicator, and that is going to be just an LED. Okay, so we'll bring that in. So that's the Boolean indicator. I find it on the front panel, Boolean, and right here the round LED. All right, so you do the proper labeling, and that is your for loop. Now let me just close this to get rid of all these changes. Don't save, and now I'm just going to bring it back up, and I'll tile left, right. So your finished product should look like this. Okay, and I just need to move things over a little bit, resize this, bring this over like that. As you can see, I can't see everything easily all at once. But this, let's just run this, and I'm going to show you this thing called data flow programming, and how we're just going to maximize this. We're going to show you how this works. Okay, so for this one, I don't want you to use run continuous. I want you to use run, because the while loop will keep this thing running until we hit the stop. Okay, now what happened to my nice little box that I created around here? I didn't save that change. All right, but let's run this single run. Okay, now because we're in a while loop, it's just going to let me keep putting numbers in. All right, so while I'm doing this, I'm just going to come over here and show the block diagram. Right now, the execution is stuck right here. Okay, it just keeps going around and around and around and around, and it's not going to end this while loop, okay, until I hit this stop button right here. Now notice the 6 plus 2, that was evaluated, but the difference has not. So let's come on over here. So the 6 plus 2, that got done already. It's 8. But this difference, which is this number 4 times 10, that's not showing up with an answer yet. And this shows the whole idea behind how LabVIEW executes a program. LabVIEW will execute any function as long as it has all the inputs ready to go. So the 6 plus 2 is done probably the first thing because LabVIEW immediately sees this function has everything it needs to operate, so it's just going to do that operation. Now inside of here, we're in a while loop. So nothing outside of the while loop that depends on something inside of the while loop, like this multiplication right here, this diff times 10, this multiplier right here is waiting for a final input from the while loop. And what happens is you have this thing called a tunnel out through. Well, this tunnel is not going to send any values until the while loop stops. So watch what happens. When I hit stop, okay, you're going to see the while loop light come on. Okay, so this is going to tunnel through, and you're going to see the difference all of a sudden go to 40. Watch this. Stop. Okay, it went to 40. So just keep in mind how LabVIEW executes a program. It will do any operation that it has the inputs for. So it'll see the 6 plus 2, it'll do that first. It'll see that it has a minuend and a subtrahend, so it'll do this subtraction. But then it's stuck in this loop, and it stays in this loop and will not do any of these operations, the diff times 10 or the while loop done. Won't do those until the loop is done and it sends the other inputs for those functions out. So in a nutshell, what determines when an operation will be performed in LabVIEW? When all the inputs to a function are ready, LabVIEW will execute that function. And while loops will continue to run until you get a stop signal into the loop indicator. Okay? So that is your tutorial 2.2. Now we're going to go on to the problems on page 56. So I'm just going ahead, and our first problem is problem 2-3. Now this one should be a pretty easy one for you. So I'm going to close this one down, and I'm going to bring up problem 2-3. Okay, and I'm just going to show you the front panel. Now you're going to use the compound arithmetic, and we did this in chapter 1. Okay, so there's no while loops or anything. You're going to have 4 controls and 1 sum. So we're going to just test this out. We can put in different values. So this is really a review of something you've done before. So problem 2.3 should not create any problems for you. All right, so run it. I'm going to execute or abort the execution, and I am done with that one. Okay. All right, we're moving to problem 2.4. And this is doing a quadratic formula in LabVIEW. Now, this is a nice exercise in how to use different functions. So this is problem 2.4. All right. Now, when you do this for your instructor, you want to first start out with testing it with the values in part A of it. So, I'm going to just test this out. I'm going to put A is 2. That's the coefficient in front of the x squared term. B is minus 2. That's the coefficient in front of the x term. And then minus 4. So you put those in and you get 2 roots. Now, one of the questions is, well, what happens if you put in something like part C, where the b squared minus 4ac is the b squared is bigger than 4ac, or it's less than. So try that one out. That's where you put 2, 1, and 2, positive 2 I'm not going to do it here. I'll let you do that. All right. Now, I just want to give you a little sneak peek of what this looks like. Okay. So I'm going to tile left, right. I'm just going to show you some of it. Okay. So you're going to put in your B, your A, your C. I put B on top because it arranged. Notice how I have labels on all my functions. I don't have one on this multiply. I should multiply. And I can move these labels using the arrow keys. Okay. Now, to keep track of things, so I've got a square, I put in some extra labels like, okay, after this, this is the b squared. So I double click on this and I could just put b caret 2. All right. So it's good to put maybe some labels out after your functions. Negate, there's my negative b. All right. I'm got to multiply. Now, I got a multiply function here. So how do I multiply by 4? You take one of your inputs, you right click, and you create a constant. Okay, it's going to come up with a default of 0. I can just put a 4 in. All right, so if there's cases where you want constants, you just go right click and you create a constant. If you wanted to create a control, you could, but that's where you get. So I've got the 4a times c. Notice I labeled that. And over here I got the 2a. Okay, so you're going to continue this on and implement the formula. And I'll leave the rest to you. Okay. But so I want you to test it with the values for part A and then for part C. All right, there's the quadratic formula. Have fun with that. I'm not going to save that. Let's move on to problem 2.5, part B. And that's on page 58. Okay, so part B, we would like to put in 4 Boolean sliders. Okay, so let's take a look at what that looks like. So this is problem 2.5. And where are you, 2.5? There you are. All right, so the book tells you A, B, C, and D are is kind of a binary number. Okay, so really I could put another label up here and say binary number. So this would be a nice label. So it's the binary number D, C, B, A. Okay, with D being the most significant bit. And over here, this result, instead of saying just result, probably be more indicative if we said the decimal result. Okay. So what we're doing is we're converting, and I'm using arrow keys here, converting from a binary number, which is zeros and ones, into a decimal result. Okay. So let's just watch how this works. So I'm going to do a run continuously because there's going to be no while loop here. So this is a 0, 0, 0. All the buttons are down. Now if I put this least significant, I add a 1. This is the 2 to the 0 place, which is the 1's place. This is the 2's place. I bring that up. Notice it's 3 because it's 2 plus 1. This one is the 4's place. And this one is the 8's place. When you put them all up, you should get 8 plus 4 plus 2 plus 1, which is 15. Okay. Now, I'm going to stop this, and there's a new function that you're going to need, and this is it's Boolean to 0 to 1. Okay, so let me just close this so you don't see the whole solution. Don't save. And I'm just going to put up a blank VI here and show you where that function is. Okay. So when you're in a block diagram, you can right click. It's going to be in the Boolean palette here, and there is a Boolean to 0, 1. What this does is you notice that if I hover on this, it has a green dot on the left. A green dot means that that this is a Boolean. It's a true or false that's going to come in. And on the right side, I've got a blue dot, which means that's an integer. That means it doesn't, it's a whole number. It could be, this is only going to be a 0 or 1. Now, when you put this into your function, nobody's going to know what question mark 10 is. So you're going to right click visible item, you're going to put a label in. Okay? So make sure you put a label. This is one of those arcane or esoteric little functions that people don't use much. Now I'm just going to tile left right. So we've got this function. So all I'm going to do is I'm going to wire in a control. Now controls, we go over to the front panel. So I right click, I'm going to go here, and it looks like it's vertical slider that I'm going to, is mine usually vertical slider? Yeah, for this problem. All right, so I'm going to do that. Now what this does is I come in, I wire that in. Now on the right side, I could come over to the front panel, right click, and now put in a numeric control if I like. There's another way. You could go over here to this function, you can right click, and I could create an indicator here. Okay, so there's my indicator. Notice by doing it using the function, LabView automatically comes in with, let's look at the data type. Properties, it's blue, so it's an integer. So it automatically comes in with an integer 16. It automatically matches what this wants over here. Okay, so this output. Now let's take a look at that if I did it in a different way. And this means there's a loose wire. I'm going to delete it. If I just created the numeric control, or indicator over here, notice it comes in as double precision, and if I wire that, well, I got to wire it from here over to here, I guess. Notice we get that red. Let me just clean up this wire. Let's right click. I'm going to right click on this wire, clean up the wire. Okay. Now, if there's a crook in the wire, I can just use the arrows and move it up. But my point here is that there's a red dot there. That's the coercion dot. So this is an integer, but we're putting it into double precision. Now LabView will do this for you, but generally in programming you want to match the data types. If there's a blue coming out, we want to indicate it with a blue. So you'd come over here, go to properties, and you could change this to display format or data type. Instead of double precision, which is a floating point, you just go to an integer. An integer 8 should be plenty. Although this function, for some reason, it still has a coercion dot, so it's not exactly what it wants. So it looks like it's actually outputting it in this format I16. The others would work just fine, but that's just something I wanted to show. All right, so remember, green is Boolean, true, false. Blue is integer, and orange is floating point numbers. All right, so having that there and knowing how to use the Boolean 0 to 1, you should be able to do problem 2.5b. Okay, that brings you to instructor problem 2.1. So I'm just going to leave this here, and I'm going to open another VI. So this is instructor problem 2.1. And I'm just going to show you the front panel for this. Now notice that this is white, the input time in seconds. So I'm going to run this in continuous mode. So for instance, if I put in 50 seconds, the equivalent in terms of hours, minutes, and seconds is just 50 seconds, 0 minutes, and 0 hours. Once I get to 60, I want this to be 1 minute and 0 seconds. So we want to make the hours and minutes as big as possible and the seconds as small as possible, because that's how we do time. If I put 61 in here, 61, then we're getting 1 minute and 1 second. Okay. Now there's 3,600 seconds in an hour. So when you have 3,600, we should get 100. If I make this number, 3661. Now we should have 1 hour, 1 minute, 1 second. And that's what you should test when your instructor comes along. All right. Now, how in the heck are you going to do this? Okay. Let me go back to my untitled VI here. Okay, so I'm going to do a little something here to show you some things that you're going to find helpful. All right, you're going to find helpful on this instructor problem 2.1 to use a function known as, let's see, I got to find it here. It's quotient. It's this one right here. I'm going to put a label here for you. Label, quotient and remainder. Now, what does quotient and remainder do? Okay, I mean, you could guess, well, it's going to create a quotient and a remainder. It's like doing long division where, you have a quotient and you're going to have a remainder. But let's go up here to help, show context help, and let's see what this says. Okay, so over here it says it computes the integer quotient. Now the quotient is the whole number part of the problem, and then it also gives you a remainder. Now the way it does this with floor and stuff, it means it's rounding in certain ways. But for now, let me just show you an example of how it works. All right, so I'm going to turn that off. Just show the context help. I take that off. All right, so the easiest way to wire up a function is I'm going to right click. Okay. So the thing up here, I'm going to create a control. Okay, so that's X. That's the numerator. Okay, so I'm just going to rename this numerator. And it's up here on this corner up here, so I'm just going to bring that down. So I'm going to get numerator, and then we're going to put in here another control. We're going to create control. Now notice once again, because the quotient and remainder function wants floating points coming in, when I do this create control, it automatically puts in the right data type, denominator. Okay, so denominator gets placed way up there. I'm going to put it down here. So we're going to make this look like division. Okay, so I'm going to do some decorating. I'm going to do a thick line. So there's my thick line. So I'm going to go like this. Then I'm going to use the arrow keys. Just click on it. Move it down with the arrow keys. Move it left. Okay, so numerator divided by that, and I'm going to create a couple more controls. So visible item, create, an indicator here because it's going to be, so that's what it's actually doing there. It's taking X minus Y times floor. So effectively this is giving you the whole number part. So this is the quotient right here. So I'm just going to change this name. QUI quotient. I got an extra I in there. All right, just bear with me on the spelling error. Okay, right click, and we're going to create another indicator. And this is going to be what we're normally going to call remainder. Okay. All right, so let's just move these things down here. And I'll just move the remainder over here. And I'll just put an equal sign there. Okay. And we could pretty all this up a little bit more, but I don't want to waste your time doing that. Okay, so we're going to do numerator divided by denominator. So I'm going to run this little VI, and I'm going to show you how quotient and remainder works. Okay, so run continuously. 0 divided by 0 is not a number. Okay, well, what's 1 divided by 0? It has a remainder of infinite. Okay, all right. Let's take Let's take 60 for instance. Okay, so let's say that we wanted to go from, let's say this was seconds up here, and this is how many seconds there are in a minute. So if I put in 1 second, I would have a quotient of 1 and a remainder of 0. Now, I have this exactly wrong, don't I? Okay, I've got to relabel this. So I got to call this thing down here. This is my quotient. Maybe this time I can spell it right. I guess I did have it spelled right. And this is actually the remainder. Okay. All right. Now I think I got it. I'm going to turn off the context help. Okay. So I'm just going to move these around a little bit. All right. So that's the quotient. This is the remainder. Okay. Got it now. All right. So let's go back to running this. So if I do 1 divided by 60, 60 goes into 1 0 times and it has a remainder of 1. If I put in 60, okay, 60 divided by 60 is 1 and there's no remainder. If I put in 61, now I get 1 quotient with a remainder of 1. All right, so you're going to probably have to use a couple of these quotient remainders in the instructor problem 2-1. All right, maybe even 3, okay, for your hours, minutes, probably 2 of them, hours, minutes, seconds. Okay, so hopefully that'll give you a good hint for 2-1. All right, 2.2. All right, let me just show you how that one works. I'm going to stop this execution and I'm going to open a project. Okay, let's do this. Let's close this one down. And we will go to instructor problem 2.2. 2.2. It's down below. Right here. Okay. I'm not going to show you the front panel completely, or I'm sorry, the block diagram, but I want you to see how this thing works. So I'm going to go to run continuously. So this is a vending machine. So you can put in dollar bills. Notice if you put in $1, input is 1.00. Now I want you to have all your money and change in decimal form like this, with 2 decimal places and always showing 1 decimal or 1 place to the left of the decimal. Now how do you do that? You're going to right click on that and you're going to go to properties. Okay. Well, we're going to use double precision. Now we look at display format. Okay. I want 2 digits of precision and use a minimum field of, I have 4 here. It could be 3, but 4 it will work. We want a pad with spaces to the left. So in other words, if we have something where we only need 3 digits, it's going to put a blank to the left. Okay. So that's what you want. 2 decimals of precision. So let's go back to running this again. All right, so I put $1 in, I put a quarter in, I got $1.25. I put this in, I got 35. I put a nickel in, I'm up to $1.40. Okay. Now, if I want some gum, which is 40 cents, notice I have a cost of 40. My change, I should get $1 off. Now, if I decide to buy potato chips, okay, now I've spent $1. I got 40 cents change. But now all of a sudden I say, I also want a candy bar. Okay, that's $1.80. I only put $1. I need to put 40 cents more in. So that's how our little vending machine should work. Now notice here that change due, if there's no change due, I want this 0. I do not want this change to come out negative. So if you just figure out the change being total input minus total cost, right now it would be minus 40 cents. I don't want you to put minus 40. If it's negative, I want it 0. This sounds a lot like Excel way back in the first week when you did the phone and used the if statement. You know, if you don't use all your minutes, you didn't want to put that you used negative minutes and get a refund. Well, at least the phone company did. So we use this thing called an if statement. Well, there's equivalent to an if statement here in Labview, and let me show you how that works. So let me create a new VI, just creating a blank VI, and I'm going to tile this thing left-right. Okay. So the function you want is this one. It's in comparisons, and it's called select. All right, so I'm going to right-click on it, and I'm going to put a label, select. If I want to know what it does, I'm going to hover over it. Notice it's got two orange dots on the left, which means it has two floating point numbers coming in, and it has a question mark with a green dot. The green dot means it wants a true or false. It wants a Boolean, and then it's going to output to the right a floating point. Now let's go to context help, show context help, and I'm going to hover over this, and this tells us what it does. It says it returns the value wired to the true input or the false input, depending on the value of S, which is going into the question mark. All right. So if S is true, then whatever I've wired to the true will come out. If S is a false, it'll bring it in here. So if, for instance, you had your change due, okay? So let me right-click on here, and I'm going to create a control. So let's say this control was my change due. All right. And let me get rid of the context help for now. And then up here, I right-click, and I'm going to create another control. Actually, I don't need a control here. Let's change to. Okay. All right, let's get rid of that wire. I'm going to right-click, and I'm just going to create a constant. Okay. So let's just keep it at 0. All right, so I'll move 0. So my output here, I'm going to create an indicator. Okay. And let's just say, so I'm just going to call this my change. And let's say that this is the result of what I've the cost. Let me do it in a little different way. Okay. Okay, so here's my change. Okay, so let me make a couple quick numeric indicators. One, and then make this over here. Okay, so let me call this one money input, and this one is going to be cost. Okay, and if I want this to look like money, I'm going to go to properties, automatic formatting. I don't want significant digits. I want decisions of precision 2. Hide trailing zeros. I do not want to hide those. I want to use a minimum field width of at least 3. Okay, so that's what we're going to do. All right, so do the same thing for the other two. Properties, 3 digits. Precision, don't hide. Use a minimum field of 3 or 4. Okay. Whoa, that's 3 decimal places. I don't want that. Okay, 2 digits. Okay, and then change. Okay, don't worry about that for now. All right, so one of the things I'm going to do with these two values is I'm going to subtract them. Okay, So my change due should be the difference between these two. So I'm going to do a subtract, just put a label on it. So I'm going to take my money input minus what my stuff costs. All right? And that's going to give me whether this is positive or negative. Okay? So let's do this. So now, if money input is more than your cost, okay, I'm going to wire that right there. Okay, and we're going to see what I'm doing in just a second. And then down here, I'm going to just create a constant, which is 0. Okay. So there's my change. Now, right here is the difference. This is money input minus cost. If that's a positive number, then I want that positive number to show up as my change. But if it's a negative number, I want just 0 to come out. So if cost is bigger than money, I just want 0. There's no change coming. So let's come in and let's put in another comparison. Okay? Let's see. Not equal, less than or equal to 0. Okay. Less than 0. Okay. So we don't want less than 0. Let me get rid of that. I can right click, I can replace this one with I can go back here and I can say, how about greater than 0? So I'm going to right click visible greater than 0. So this is a Boolean test. So if I take that right there, if there's less money put into cost, or if there's more money put in, then there should be change due. Okay? So watch how this works when I run in continuous mode. Okay? If I put in $1, notice that the change is 1. But let's say I buy a bunch of stuff, and I buy $2 worth of stuff. The change is 0. Okay? Because the way this test does it is if this subtraction is not greater than 0, okay, we're just going to put out the 0. If we put in more money, notice I get change now because this will be a true. All right, so give that some thought. Hopefully that's a good hint for you using the select and the greater than. So hopefully you'll have a nice vending machine up and running before no time. Hey, thanks for coming for Chapter 2. I hope you found some useful stuff. Okay, so till next time, John Waddick signing out.